So in today's session, we are going to discuss about the topic that is geological consideration to be taken while selecting the site for tunnel. Now in this lecture, in today's session, we are going to see in detail, in practical way that we are going to see in detail how the geological aspects of a region is going to affect the selection of a site for tunnel. Okay, so before going into the details, the first thing is a tunnel. What we call it is an underground route or passage driven through the ground without disturbing the overlying soil or rock cover. So there are a number of different kind of tunnels we require as a civil engineer. If you take some examples like a traffic tunnel is constructed basically for the purpose of traffic. There we can do construct the road and the vehicle can pass through it. Then there are the major second kind of construction is a hydropower tunnel. So hydropower tunnel is what we call it is the to transfer the water from the reservoir to the powerhouse. So there are tunnels we provide through which the water from the reservoir can pass through or go to the powerhouse, and where it will be used to rotate the turbine to generate the electricity. So that kind of tunnels which we call it as the pressure tunnels, and whereas in the hydropower tunnels we have another kind of tunnel which is called as a discharge tunnels. So these tunnels are used to convey water from one part to another for any purpose. And the third kind of tunnel we call it as the public utility tunnels. It may be a sewage tunnel, or it may be any kind of utility, a subway or a passage. So in any of this kind of tunnels we are talking about, for example, if you see the metro stations or metro network in Calcutta, the entire metro is going underground. So the entire city, where below the city there is a tunneling, so through which the metros are running. So that way, but where in the case of if you see in the Delhi or if you see in the Bombay, where all the metro, all the rails are not running through the tunnel, so it is not underground. So there are geological reasons to do that. For example, if you see the Calcutta, there the geological characteristics of the rock type was very perfect, so that it was having a loose to semi-loose material to do the construction or tunnel, and that was easy to do the construction. Whereas in the case of Delhi, if you see that the rock types which are existing there, they are mostly of metamorphic to igneous rocks, and through which the construction of tunnels was not economical. Or in the same case, if you see in the Bombay, where it is all decant rock covered, volcanic igneous rock covered, so through which the tunneling process was not feasible comparing to the subsurface metros. So basically, the concept is that in any kind of tunnels we are talking about, there are number of geological parameters. That is what we are not having any control on, but what we have is the control on the design. So based on the geological characteristics of the region, we do construct the tunnel in that area. While taking that locations, there are number of points as a geological point of view we have to keep in mind. The first one, it comes into the selection of tunnel route. For example, if we take the example of Atal Tunnel, the road which is going, that is what the Rohtang Pass. So it is all road which is going to connect these two cities. So where there are number of alignments we can talk about if you need to connect here. So you can go for a tunnel which is going through directly from here. I can go for a tunnel which is going directly through this point. I can go for a tunnel which is directly. There is number of ways I can do a tunnel on this hill, where it will cut across the hill and reach the other part. So while taking this kind of parameters, we need to take the care of the natural geological characteristics of the area. So a detailed geological characteristics needs to be studied to assign or understand the best possible alignment for the tunnel. So that is one thing. Second one, it is a selection of excavation method. If you remember the last week lecture and what we discussed, there are a number of different ways. It can be a tunnel boring machine, or it can be a blast method, or it can be a any kind of method, manual construction of the tunnel. Number of different methods can be adopted for the construction of this tunnel. While during these all different methods, also we need to set up things. What, how much would be the depth of the borehole to be blasted? What kind of how much would be the per day we can blast? So there are so many things. The things needs to be decided based on the natural characteristics of the area. So that whole idea we get from a geology, detailed geological characteristics. So selection of design of the tunnel, what kind of tunnel it is a circular tunnel or semicircular, D-type. Number of different cross-sectional types are there. So what kind of tunnel, what we are geological characteristics of the area, and this geology is having a lot of effects on the stability and cost of the construction of the tunnel. Okay, so if it is having a very hard rock strata, then the tunneling on that strata may be a little difficult, but it will actually act as a naturally it will sustain without having any support. So the cost of supports are reduced. So that kind of analysis needs to be studied. The stability and cost, these are all interlinked. So that kind of analysis and the discussions are being done with the background of geological characteristics of the region. And finally, the objective is comes to the assessment of environmental hazard. So, what kind of environmental hazard this selection is going to be created by the construction of that tunnel. So, these are the basic objectives, and this is the stages what we follow. It's the first one. It is the preliminary geological study, preliminary survey. So, in the preliminary survey, when you are talking about, for example, this region, the Atal tunnel location. So, if I go to the terrain, see that the terrain is something like a hilly terrain. We see here. Okay, so this is the road which goes to, and this is where the Rohtang pass is going through. The Rohtang pass, it connects to this two main roads. So here is how where we have just seen that the construction of the tunnel is done. Okay, so it started from here to here. So while doing these studies, we need to study the entire topography of the area. So we have to see if we are able to see that, but the hill what we are looking at. So this is where we are going to do the construction activity. Okay, so the topography of the region and where we are cutting, where we are going. So once we start the tunnel from here, when I land up in the other part, it has to be in a same elevation, or it has to be in a designated elevation. So the regional topography of the area needs to be studied for that purpose. Then if you go to the second thing, then it is the lithological characteristics of the area. Lithological characteristics of the area means when I'm going to study about the characteristics or the rock types of this area, so I will have to see a geological mapping on this entire region, and then I will identify that what kind of rocks are there. So how these rocks are composed of, what is this hill composed of. If you remember, we have done the geological mapping exercise. When we have done the geological mapping exercise, we have done the same thing. What we have done, we understood the hilly terrain, and when you discuss about a hill, each and every hill in this region is composed of different varieties of rock types. So what we have to do is a geological mapping of this region, and that geological mapping of that region will give you an idea, give us an idea that what kind of rock types these hills are composed of. It will give an idea whether the rock types in this region are horizontally arranged, or the rock types in the region are vertical, or they are inclined, and how many number of layers are there, what all layers we are going to cut across when we do the construction. All these different aspects of the area we get to know from the geological characteristics of the region. Same thing, we have to get to know about the hydrological conditions of the area, because this is a hill, and if this is the water table present in that region, and if I am going to construct a tunnel across this, that means I am going to cut this water table. So as we know that when we cut this water table, all water which is present in this area is going to flood into the tunnel. So that is going to create a flooding effect on that. So what usually have to do is that we have to do a detailed analysis that how and to what depth this water table are and how it is going to affect it. And if you realize that the water table is much higher than that of this expected of this proposed tunnel height, then what a general idea is done. We do a pump or a tube well here, and then do a pumping. So this pumping will reduce the water table slowly. If we increase the pumping, slowly the water table will come down to the post tunnel height. Then we do the construction of the tunnel, finish the tunnel, do proper lining, and then after completing all this tunneling of this process, then stop the pumping. So then the water table will come up to the original position. So in this stage, the understanding of the water table, that at what depth it was, it help us to decide, okay, this is the process I have to follow. So that kind of understanding needs to be done by the geological characteristics of the area. It includes the hydrological conditions, water table conditions of the area. Okay, so that also comes under the characteristics of the preliminary survey. Then it comes to the structural conditions, whether it is a fault terrain or whether there is a fault in that hill. Okay, so all these different characteristics of that area needs to be studied for the structural characteristics. Okay, so once we do all these primary characteristics, then it goes to the, and then we decide, okay, I'm going to do the construction of the tunnel on this part. So this is my tunnel alignment. So it connects my tunnel to the two faults. Okay, I know that I'm going to cut across a fault. There is one trouble what I'm going to calculate, and I'm going to take that risk by cutting across a tunnel. Then we need to understand these all individual characteristics in detail. So these individual characteristics will be studied in detail by making the different boreholes. So while doing these boreholes, we do a lot of characterization of these rock types. We call it as rock quality designations, rock quality measurements. We classify the rock types based on its characteristics, what kind of characteristics are there. So we do take the sample and we take the characteristics like mineralogical composition. Then we calculate the modulus of elasticity, porosity, and permeability, general chemical characteristics. The entire details will be characterized on all these different samples. So all these boreholes what you are making will be doing for the sample collection and the laboratory analysis. So this is a long method of laboratory analysis we will follow, and this laboratory analysis will give us a detailed result of the rock types of that region and how that is going to be behaved. And at the end of the stage, by including all these characteristics, what we prepare a geological map, and that geological map will have all the details, and from that geological map I will prepare this cross-sectional view. And here I have decided a particular height through which I am going to do the construction of the tunnel. So this tunnel is going through this area, and in beforehand the geologist beforehand the civil engineer is getting into the starting of the tunnel. He is having an idea, okay, I am going to do a construction of a tunnel through this region, and there are number of different rock types, 1, 2, 3, 4, 5, 6, 7, 8, and there are number of different fractures on the number of different varieties of rock. There is a fault. So all these things I am going to do the construction of the area. So this is what we call it as the geological cross-sectional map of that area, and that is to be prepared well in before the construction of the tunnel. And then we do see these are the exploratory bore access holes. So there is a bore access hole. There is a number of different characteristics, fault zone, schistosity, boreholes. So this geological cross-section will be having the location of the tunnel, type of rock, structure scene, hydrological conditions, and even the ground temperature of that area. Okay, so these all things together is what the geologist has to prepare before starting the process of tunneling by a civil engineer. So the engineering team, before they start with this process, they will have this geological map prepared and ready for assessment at any time. And now the process of construction will start one by one. This is called the process of tunneling, and this process of tunneling we will have the exploration during the construction. So after every process of tunneling, when we break one area, so the geologist team will come and see the rock types and to compare it with the geological cross section and the interpretations that how they have made from the study. So this information, if it is matching, then it is good enough to go ahead. But if in case the situations are not matching and if they detect any other kind of geological features and any other kind of changes in the interpreted part, then they have to stop there and to do find the solution that why is it coming. That is first you have to check, and if it is anything problematic, then the geologist has to recommend the solutions for that. Then it has to go ahead in the process of tunneling. So now, when you are talking about these geological considerations, there are basically two kind of rock types. What we know that one is called the consolidated rock types, and second one is the unconsolidated rock type. Consolidated rock type means it has the hard rocks like metamorphic or igneous rocks, through which the construction process is little bit harder. Cutting these things are little bit harder, but the process of cutting is easy because the rock will have its own stability, because if you cut a tunnel on an igneous rock, the rock itself can take the arching action and there is no need of supports to be provided. But in the case of unconsolidated rocks, if you are doing the tunneling, then we have to provide supports to that. Okay, so this is a extra work, but here the rock is a hard rock that it can take the load by itself. There is no need of extra supports to be provided. But in this case, the rocks are loose. It is not able to take the load from this area, so it has to take a support on that. There are few more things which controls is the geological structure of the area. So the geological structure of the area, like the what is the dip, what is strike, what is the presence of fault, what is the presence of foldings, and where the joints are, what are the directions of the joints. So these all things actually affects the design, stability, and the cost of the construction. Okay. So if you briefly discuss that what are these geological conditions one by one. First, let us see that if the area is having a horizontally stratified rock strata. That means I'm going to construct a tunnel across a hill. I'm taking the examples of hill because that is easy to visualize. And this is the condition of the tunnel, and I'm going to do the tunneling across. So here the rock types are all horizontal in nature. So in this case, when the rock types are all horizontal in nature, if we construct a tunnel here, so this is actually a safer condition because the tunnel is cutting on a one single unit, and as a benefit, the entire length of the tunnel we will get a uniform kind of rock. We are not going to get any other kind of rock. And along with that, there is a contact here, and if you consider this contact here, then there is the chances of overcutting are less because there is a weak plane, and when you blast or when you do any kind of construction, so this area will break only up to this contact plane. So that is a very favorable condition. So I'm going to get a uniform rock type, entire duration and the entire length of the tunnel, and this overcutting problems I'm going to avoid if I construct the tunnel on a one single layer of rock. So that is in the case of a horizontal thick stratified rock. Okay, the rock type is thick. Now, in the same case, if I'm going to construct the tunnel in a thin laminated or thin bedded strata, okay, in this case, where the problem is that while during using the construction, we are actually doing construction on two different varieties of rocks. So this is one step variety, one rock, and there are another rock. Okay, when you do the construction on two of these different rock types, the methods are going to be different while proceeding further with that. If you are going for a tunnel boring machine, or if you are going for a manual, or if you are going for a rock blasting technique, any technique we are going for, the both the things we have to always keep in mind that we are going to do the construction in two different varieties of rock. At the same time, because the layers of the rocks are thinner in nature, this arching effect and the natural bridging effect of these layers, we cannot trust on that. We cannot trust completely on that. So it may require the area to be provided some kind of supports to stabilize this area. So that support needs to be given. Whereas in this case, because of the thick layer, it was actually taking by its own weight and it was actually creating the bridging action. and the support was not necessary unless and until it is not having any structures. Okay, if they're not having joints or faulting, then there is no need of any structures. But in this case, the layer is thin, so we cannot believe completely on this. So we need to give some support on the to stabilize the rock strata. So that is one thing in the case of a horizontally stratified data. Now, if you take the second example of moderately inclined strata, that means there are rock types which are slightly dipping, they are not horizontal. So, in this case, this is the direction of the strike. We know what is the strike. Strike is the angle, the direction of a line of intersection between the inclined plane. So, this is the inclined plane, and here is the horizontal plane. So, both of them are intersecting and they are creating a line, and the direction of that line is called the strike. If I take the strike of the strata is east-west, then the data is dipping towards north. So it is dipping towards north. We can take up that, okay, now the strata is dipping towards north. I can go for different orientations of the tunnel. The first one is I can go for an orientation of the tunnel in north-south manner. So that is something like this. The tunnel is constructed and it is going or cutting across the strata. Here they are going to face number of merits and demerits. The first merit is that because we are going to cut this strata across this rock layer, so this natural bridging action will be providing a good strength to this tunnel stability. But the main problem we are going to face after cutting some distance, I will get into or landed up into another rock type. So every 10 meter, 15 meter, depending upon the thickness of the layers, we are going to get different varieties of rocks in the entire process of tunneling. That is going to create a lot of uncertainty in the process of tunneling. So that is one trouble we are going to face, that it is having a demerit. The number of strata needs to be excavated. Different number of strata need to be excavated. Now, if you want to avoid that, there is another way we can go for. We can go for a construction of a tunnel that would be running parallel to the direction of the strike, or it is perpendicular to the direction of the dip. Here what is happening, we are going to construct the tunnel using only one single strata. So what benefit we are going to get? We are going to get a uniform character of strata during the entire process of tunneling. So chances of sliding through bedding planes are another trouble, because this two strata, I'm cutting a tunnel here. Now this strata may be possible to slide down. So that is another. So thickness of the strata makes a role here. I think the strata are very thick, and if you are going to cut across a tunnel, cut across one single strata, then it is not going to produce any trouble. But if the thickness of the strata is less, and if you are going to cut across that which is parallel to the strike of the strata, then the strata may be having a chances to slide down. So here in this case, the bridge action is weak because we are cutting parallel to the strike direction of the strata. Now there is one more chance what we can go for, it's either parallel to the strike, neither parallel to the dip. Rather, we can go angular, that we can oblique to the dip and strike of the strata, which cut across the rock in an oblique way. Is neither parallel to the strike nor parallel to the dip direction, which goes oblique. So in this case, the drawbacks of both the cases will demerits of both the cases will be ineffective. So depending upon our requirement or depending upon the conditions, so we have to keep these things in mind. It doesn't mean that it is not possible to do construct across or oblique to the strata, but sometimes you have to go for that. But you have to keep in mind, okay, when I'm going oblique to the dip and strike of the strata, so I'm going to face all these different problems. So accordingly, we have to estimate the expense of the construction. Accordingly, we have to build the proposal to the people when they are going to do the construction. So this all detailed understanding that can save your sometimes a detailed understanding can make you to estimate the things correctly, then that may get you into the business. And if you are doing these things wrongly, then that will lose your money also. And if you are not considered all these aspects, and if you consider that the entire strata is going to be uniform, and I'm going to do 20 meters a day tunneling in this terrain, and if you start the working, and if your strata every 5 meters you are getting different varieties of strata, and every 5 meters you have to test and to do the tunneling, change the tunneling method, and it will take your time, a lot of time doing that things. And when you realize that, okay, it is taking a lot of time, that time is your money. But because when this kind of major things, there are so many things which are involved, so many things which are connected. So this time is the money. So a proper visualization and understanding of the region will help you to take these things very carefully, and that will help you to ultimately improve the stability of the structure and the cost of the reduce the cost of the construction. So that is what the reducing cost of construction is what is the profit of the engineer. So the as best you can reduce the cost, as best you can get the profit out of that. So when a real proper understanding of the geological characteristics will help you to improve the stability and reduce the cost. That is what our profit it will get out of the get out from the project as a civil engineer. Okay, so this is second condition where the moderately inclined strata. Now, if I go for the third condition, that is a steeply inclined strata. So there are two conditions. Okay, so here the rock strata is steeply inclined. So we can go for two conditions other parallel to the strike direction. So here the same way what you had discussed in the previous slide, which is having a trouble that this when you cut this, so this entire block may come down and it can create a sliding effect. But if you are doing the construction something like this, which is within only one layer, then that may be as a we can consider as a good way of construction or good stable construction. But or if you are going to do a construction something like this, here the problem is that we will be cutting across two layers, but the stability will be more. So this is one way. Second way is to do the construction parallel to the strike. So that is what we are shown here. Here the rocks are dipping in this direction, and we are doing the construction that is parallel to the direction of the dip. So here this would be more stable compared to the first situation. And here also we can go for the same angular to this. So there also it will have all the drawbacks of both the situations in the angular pattern. And now we have to discuss basically about the process of construction of a tunnel in a folded strata. So if you remember when we were discussed about the folded strata. So when a rock layer which is folded to a process of pressure, that the process which you're folding the rock maybe of anything, and as a result when the rock gets folded there are different parts it forms. So one portion we call it as a limb. This is two limbs, and we call this as a crust of the portion. Then we discussed there are different varieties of faults. We call it as a synclinal fault, and we call it as an anticlinal fault. So there are different terminologies we have already discussed. So right now we are discussing about the terrain where there is a folded strata. So this strata what you are seeing on screen right now, this is a anticlinal folded strata. Now, when you are talking about the construction of a tunnel in this strata, there are different possibilities of construction of tunnel, different alignments we can go for. First one is something like that. We are cutting across the tunnel. So it is starting from the portion of the limb and it is going through the core of the fold and coming out of the crust. Okay, so we are cutting across the fold. If we imagine that the axis of the fold is this, we are running parallel or perpendicular to the direction of the fold axis. This is what we are going to construct. In this case, when we are going to do the construction of a tunnel, we have to keep the things in mind. This portion of the fold is stressed because this we are doing the construction in the limb portion, and this portion of the fold is also not going to be under very high stress because we are cutting in the limb portion of the fold, whereas the portion which is under high stress and strain is the crust portion of the area where it is highly stressed is the core portion of the fold. So while considering this alignment for the construction of a tunnel, we have to keep always in mind whenever we reach this region where it is the core portion of the fold, which is under very high stressed region, because that rock has got folded. As a result, the rock in that part would be highly stressed and strained. There would be number of pressure joints or the fractures which must be there in the rock. So the person who is going to excavate this area should be informed well in advance that okay, you are going through the core portion of the fold, and when you are going for the blasting, if you are using the blasting technique, you have to tell them that the person that you are going to cut the core portion of the fold, then you have to keep in mind this rock in this region is highly susceptible to over cutting. Okay, so this is what one thing we have to keep in mind. The second thing what we can do is an alignment where we can do the construction of a tunnel on the limb that is parallel to the direction of the fold axis. Okay, so we are going across, we are going along the fold. So in this case we are going all along the limb of the rock, so that may be a good condition because the limb portion is having limited or the less amount of deformations compared to the crust portion. So this is a favorable condition for the construction of a tunnel, and the direction is going parallel to the direction of the fold axis. So both the limbs we can be taken in that case. Now if we are going to construct the tunnel on the crust of the fold, so that is the really bad condition to go for because of the high amount of stress in the rock in this region. And anytime you have to keep in mind, it doesn't mean that we cannot do the construction, but it has to be go through a very tough time for the construction people to cut across this crustal portion or the trough portion of the fault, where the rocks in this region is highly stressed and strained. That always we have to expect a chances of overcutting, and when you do a blasting, a lot of things which go falling down because of the amount of fractures or the secondary fractures formed by the process of folding. So this is one situation, and the second situation is that if you consider inclinal region where the rocks are folded downward situation, we are taking the same examples where it is an up the same things what we have discussed just now. We are cutting across the highly strained portion of the fault, so it will have create a lot of trouble. So whatever we have just discussed about the anticline fault, the same things will be applicable to here also. So here number of different difficulties we will be going to encounter, the number of different layers, layer 1, layer 2, and then we have layer 3, layer 4, that different layers will be coming. And there will be repetition of layers. One layer what you are getting in this bed, same layer will be coming at this portion, and the rocks are under highly stressed and strained, so that will be releasing a lot of pressure when we cut. So overcutting is a common thing we can be expected in this region. Okay, so these are the basics about when you are to keep in mind while you're taking the selection of a site for the construction of tunnel in a folded region. Now similarly in the case of a faulted strata, so here if you see this is one block, we call it as a hanging wall or foot wall. We call it as a hanging wall because the block is above the fault plane, and this we call it as the foot wall. So the hanging wall moves downward compared to the foot wall, so this becomes a normal fault in this region. This is a normal faulted region. Here one location I am considering is across the fault. So this is a really troublesome location for the construction of a tunnel, because what we are doing is that we are cutting across the tunnel, cutting the tunnel in a will parallel to the fault plane. This is the fault plane. Okay, so parallel to the fault plane, you are constructing the tunnel across the fault line where there is a break and there is a movement we know, and across that we are going to construct the tunnel. So it will happen after the period of time that the tunnel also may get distracted because there is a chances of displacement across the tunnel. So we need to have a very detailed study before going to construct this kind of a tunnel. We have to make sure that there is no chances of activation of this fault in any time in the future. Then only we can go for this condition, and this is the very worst condition we can go for the construction of a tunnel. Unless and until we are not having any other option to take up, and there is really compulsory to do the construction on this line, then only we will go for this with a lot of precautions. So we have to go for the complete stabilization of this. Maybe go for the bolting, maybe go for the plugging of these faults, and make sure that there would not be any movement, and a proper lining and a proper checking in every day in a regular interval that of any kind of movement, and even the water or the faulted things can be get into this tunnel through this fault plane. So that kind of all unavoidable circumstances need to be taken into consideration while considering this location for the construction of a tunnel. Second option is cutting a tunnel which is parallel or perpendicular to the direction of the fault plane. So this is the fault plane. We are going to come in a normal strata till here, and the point when we cut here, we will get the so this area where we are going to cut, so we have to keep in mind that okay, this is a faulted terrain. So this zone we call it as a fault zone. So the fault zone, the rocks will be of highly crushed and grinded, and there would be number of disturbances. So cutting in this area is very troublesome. Now, one more thing which is basically affecting the construction of the tunnel while we are working on is the groundwater condition. So in this condition where the water, the tunnel is going to construct in a completely saturated terrain, where in this case the tunnel is going to completely in the unsaturated terrain. So this is basically a safer condition where there is no water be getting into the tunnel. But in this condition, when we do a tunneling, water will be percolating into the tunnel. So that is a troublesome situation. What we do is that we construct a pump, a bore well, and we pump the water from the this terrain, and then we make this water table to be deep, go down, and then construct the tunnel, then stop the pumping process. So this kind of processes we do in areas where we are going to construct the tunnel in a water saturated conditions. So this water entering into the tunnel is a really troublesome process. So I think by this we got a general idea about the things to be taken into consideration while going for the selection of a site for the tunnel, and the selection process and the reports of that site what you are going to select will be given by the geologist, and as a civil engineer we will be only interested to read that report and understand the concepts or the idea what the geologist put forward, and we take our decisions accordingly. That is our primary duty. So whenever there is a report which is mentioning all these things, your decisions on the construction or the alignment of the tunnel and the parameters should be depending upon the natural characteristics existing in that region. That is the only thing as a civil engineer we have to take into consideration.